All right, hello there. So today we're going to talk about square roots and solving quadratic equations with square roots. So here we go. So remember your perfect squares. All these numbers in your multiplication chart right down the middle, these are all your perfect squares, right? Because like 49 is 7 times 7, 64 is 8 times 8. So if somebody were to ask you the square root of all these numbers, you would know that perfectly. They have perfect answers. So if somebody would ask you something like, oh, what's the square root of 25? That one's right here. So you're like, oh, that's 5, right? What's the square root of 36? 6. What's the square root of 121? 11. So all those perfect squares are easy to know the square root of. But we also will have to run into things that we don't know the square root of. So anyway, you might want to find yourself a multiplication chart to print out if some of these things, like for factoring and things that are a little bit, some of your multiplications are not memorized. But here we go. So take some notes here. We're going to do a few examples of just some basics, but first we're going to talk about reducing radicals. So today we're going to be solving quadratic equations with square roots. So kind of a long title, but you remember how we solved quadratic equations by factoring. That's how we did that first, and then there's a couple more ways to do it that we're going to learn in class as well. So with square roots. So first of all, let's talk about square roots a little bit. Like we talked about how if you have a perfect square inside there, you're like, okay, bam, it comes out to a nice, quick, and simple answer. So if you have a perfect square, you can always use a calculator to do that. But if you don't have a perfect square, you're going to have to not use a calculator because we're not interested in decimals. So if you have something like a square root of 44, and you have to break it down. So some of you guys use the birthday cake method, and so I think what you do 44, you go like that, and then you do 2, and you do a little thing like that. I don't usually do it that way, and if you know how to do it that way and you love it, go ahead. I'm just going to start writing out my factors here of 44. I want to get it down to my prime factors. So numbers like 2, 3, 5, 7, 11, things like that. Those are all prime numbers that multiply to my problem. All right, 44. Let's see. I think 44, 4 times 11. So 11 is prime, but 4 is 2 times 2. Now remember, I'm looking for pairs. So when I have a square root right here, I don't have to really write it. I have a little square root right there. I don't have to write it because it's a 2. But remember, I'm looking for pairs of numbers. So I have a pair of 2s. So what I'm going to do is pull out a 2 and leave the 11 inside. So hopefully you remember that from Algebra 1. All right, so let's try something like the square root of 12. So 12, I could do 4 times 3. 3 is prime, so I'll do 4 is 2 times 2. So again, you see I have a pair of 2s, so I have 2 radical 3. All right, so let's try another one, like square root of 18. So 18 is 9 times 2, and I have 3 times 3, and I'm running out of space there. But anyway, you can see I have a pair of 3s this time. So a pair of 3s. So I would write 3 radical 2. All right, and so when you get to numbers that are a little bit bigger, so let's try like square root of 72. So 72 is a little bit harder, but you're thinking to yourself, well, it's an even number. I could at least divide it by 2, so you might need a little calculator. So I'm going to do 2 times 36. Now this is kind of a special thing. I just got a perfect square. So I have a prime number. My 2 is prime, and then 36 is a perfect square that I just found. So I could right now go and answer this question. The square root of 36 is 6. So I could pull out a 6 and then write radical 2. But let me show you why that also is true. So if I didn't recognize that, I might say to myself, okay, 36, how about 9 times 4? 9 is 3 times 3, and 4 is 2 times 2. So I'm going around, I'm looking for pairs. I got a pair of 3s, and then I have another pair of 2s. So what I do when I have 2 pairs is I multiply them together as I bring them out. So 3 times 2 is 6, producing that 6 right there. And then this 2 right here, he's just by himself, he's just going to stay inside. Okay, so either way, if you recognize the 36 to begin with, or you just keep breaking it down, you get 6 radical 2. All right, so let's do one where there's a number sitting outside. So 7 times radical 54. Okay, so remember, like I said, this is 7 times radical 54. So if I bring a number out, I have to multiply it by the 7. So 54 is 9 times 6, 9 is 3 times 3, and 6 is 3 times 2. So I'm looking for pairs, so I do have a pair of 3's right there. So I'm going to be bringing out a 3. That 3 is going to multiply by the 7, so 3 times 7 is 21. And the radical still has this 3 and this 2 left. So I had to put them back together and put them back to 6. So there we go. All right, so there are my basics of reducing radicals, and this is going to come into action when we have to solve things using square roots, which we're about to do. All right, so over to the right here, I'm just going to use this space to do a simple equation. What if somebody were to tell you that x squared equals 36? And you're like, oh, I know what that is. So that's telling you that something squared makes 36. And you're thinking to yourself, oh, well, I'm just going to go ahead and pop a 6 right in there because 6 squared is 36. So I got my answer. And so x equals 6. But what if somebody came along and they said, well, I don't want to put a 6 in there. I want to put a negative 6 in there. That would be okay also, because isn't negative 6 times negative 6 equal to 36 like I want? So they're going to say the answer is negative 6. And so both of you are correct, which is why when we get a question like this, x squared equals 36, we have to say that x could have been positive or negative 36. I'm sorry, x positive or negative 6, not 36. All right, so that is one way to do that, because you just recognize the answer. You're like, oh, 6 squared, 36, or negative 6 squared. But the main idea also is when you solve equations, you want to get rid of things. Like you want to get rid of this square right here. So like when you see addition in an equation, you use subtraction. When you see multiplication in an equation, you want to get rid of it, you use division. When you see a square in an equation, the reverse is a square root. So what I'm really supposed to do when I do these is I'm supposed to take the square root of both sides. So let's go ahead and write that on the next page, like the proper way to write these things. So if I had to solve this equation, I had x squared equals 36, and my direction in this whole page is going to be to solve. I would come along and I'd be like, okay, there's a square, so let me take a square root. And I'm going to say then the square root of the square, this cancels out. So I get x equals, and the square root of 36 is 6. But remember, like we saw earlier, I have to remember to put plus or minus. And so you always put plus or minus on your answer. So there you go. You got 2 answers. Remember, x squared, 2 answers. All right, next one. Let's say I had 3x squared equals 75. Well, this has to be cleaned up a little bit first. That 3 cannot be there when you do the square root. So you divide the 3 out. Just like when you solve equations, you get x squared equals 25. And you're like, oh, now's the time when I take the square root of both sides. So I get x equals, and I have to put plus or minus and put a 5. Okay? All right, so every once in a while you'll be doing a problem and you'll run into this where you get down to an answer that says like x squared equals, let's say 10. And you're like, okay, well, I have to take the square root of both sides, but I don't know the square root of 10. This goes away. So I'm just going to write plus or minus radical 10. Even 10 is 5 times 2, so I can't even reduce it. And so I just leave it like that. That's all I say. So remember, when you're in math space, you have to put that little plus or minus button. You have to use that there. And then you have to go ahead and put your number. All right. Oh, that looks uglier. Oh, well. All right. So a few more examples of this, and then we'll be all set. So let's say we had something like x squared equals 40. Okay, so you come along, I'm ready to take the square root of both sides, and these knock off. X equals plus or minus radical 40. Well, 40 though, I can do something with that. That's 4 times 10, 4 is 2 times 2, and 10 is 5 times 2. So I do have a pair of 2's that I can bring out. So I'm going to finalize my answer and say plus or minus 2 radical, and 5 times 2 back in there is 10. So that would be my final answer. All right, so a couple more. Let's say I had x squared over 3 plus 6 equals 10. So this one takes a little bit of work before I can do my square root. I got to take away 6. So just like I'm solving a normal equation, x squared over 3 equals 4. Multiply it by 3 on both sides. So finally I'm down to x squared equals 12. So now it's all cleaned up and I can take my square root. All right, so these knock off. X equals plus or minus radical 12, just in case I can't reduce it. But 12 is 4 times 3. 4 is 2 times 2. So I can bring out a 2, right? All right, so I get x equals plus or minus 2 radical 3. Okay. All right, so just two more problems, two more little examples we're going to do that you're going to run into on your math space. Similar. So let's say you have 36x squared minus 49 equals 0. And you're going to solve it. So you're like, okay, let me add 49 to both sides. All right, so you got 36x squared equals 49. And you're like, well, I'm going to have to divide both sides by 36. But looking at this, 36 isn't going to 49 very well. So don't go on your calculator. You don't need to divide this on your calculator. You just need to write 49 over 36. I mean, I haven't really done anything. I've just shown that I want to divide them because I do recognize 49 and 36 are both perfect squares. So that's fine. When I go and take the square root of them, the square root of both sides, these will cross off. I'll put plus or minus, and then I know the square root of these. So the square root of a fraction is just the square root of each part. So the square root of 49 is 7, the square root of 36 is 6. So there's my answer, 7/6, plus or minus. All right, last one. Let's say I have 2 and then x squared minus 5 in parentheses equals 190. Now you have two options here. You could multiply this 2 out and then go ahead and solve it like that. Or since this 2 is multiplied by the whole thing over here, what I can do right now to make my life a little simpler is I could just divide the 2 out right now. And that would be a little bit faster. So this goes away. I get x squared minus 5 equals 190 divided by 2 is 95. All right, and then I'm going to add 5 to both sides, so I get x squared equals 100. And I think I recognize that. Square root. And I get x equals plus or minus 10. Nice and pretty. All right, and that is all. And go do your math space. Bye-bye.